Hello and welcome back to CS128-Honors. In this video, we'll be talking about structs in Rust. So why do we need structs? Well, if we look at this Rust code, you can kind of see that we have a bunch of code where we have 4 different variables that are all related to each other. We have like the name, the UIN, honors, and the GPA. And then we pass all that data in and we're printing it out later on. And this gets very, very confusing though, because now we have to keep track of all 4 variables, and if we lose one, or if like, say we try to borrow one and then give ownership to another one, it gets very hard to keep track of in our minds. So this is obviously not that great. And so in terms of that, when we need to store related data, but they're not all in the same types, we want to be using structs, right? And so for example, with this student, right, the student has a name, a UIN, a flag for whether or not they're in the honors course, and then a GPA, right? And so all of this data is related to the same student, but are separate variables that we need to keep track of. And so instead, what we can do is we can declare a struct. And so if you look here, we have a struct where we take all of that data from before with the student, and now we package it all up into one variable now, right? We can now store all of that, pass ownership, everything much more simply. And so to instantiate that struct, or to basically provide it its initial values, you can do the syntax here. So as you can see on the bottom there, I have let student equal student. And so that's saying like create a variable and then make it equal to the student struct. And then inside of those brackets, and you'll notice they're brackets as opposed to parentheses, like say Java with classes. Inside those brackets, you can then put a list of all the different variables that you want to instantiate with. So in this case, we're using UIN, in honors, name, and GPA, and we're providing initial values for all of them. One other thing to note is if you take a look at the order of those variables, you'll notice that the UIN is on top as opposed to honors, right? And so you have, or name in this example, right? And so you have the order in a different way around, and that's fine because Rust is able to identify that all the different variables that need to be there are there, and we'll just figure it out for you because it's able to reorder them at compile time. So now let's talk about accessing the values in the struct. And to do that, all you have to do is just use dot notation just like you would in, say, Java. And so here we're getting the student's name just by calling dot name, and this code would print out Ewan's name here. And so as you can see, this is a really simple way to make sure that all of that data is stored in the student struct, but we're able to access all the individual pieces in a very easy manner. And then for modifying values in the struct, we now need to add the mute keyword in front of student, right? So now we're telling Rust, hey, I want a mutable student struct. Here are the initial values, and then we can then go and change them, right? So in this case, I set the GPA to 3.0 as opposed to 4.0. And as a result, the student now has a lower GPA, and when we print out, you get 3.0. One thing to note about modifying values within a struct is that the entire struct must be mutable or immutable. It can't be mutable for some variables and immutable for others. They need to be, as a collective, either mutable or immutable. So let's talk about using a function to create a struct. So in this case, we have a new student function which takes in a name and a UIN and then returns a student struct. So some things to notice here are that here we're only passing in the name and the UIN, because the student struct, when we build it, we're using a couple of hard-coded values. In this case, we're saying that every student is in honors and has a GPA of 4.0 because they're honors students, of course. And then on the return type side, we have the type as a student, as I mentioned, which is going to pass that student struct back up to the calling function. So let's ask a question of how does ownership work in this function, right? So we're taking the student and then we're making it on the stack and then we're returning it back up. So what do you think is going to happen? Well, the answer is that we are going to instantiate the student in this struct and inside, or in this function, and it'll be on the stack. Now, what's important here is that new student as a function is the owner for this student struct until we then return it, in which point we now are giving the calling function ownership and whatever you set this equal to or whatever ownership of this variable. And so all of its values are stored in new student, and then it goes back up because you're passing the entire ownership as opposed to just a reference by borrowing, right? So let's take a look at something else with this though. You'll notice here that we have the name going to name and the UIN going to UIN. And this might seem redundant, right? Like these names are the same, why do we have to do this? Well, in most languages, this is just something you'd have to do and you'd have to live with it. However, Rust is smart and it's able to tell you that you don't have to do that. So instead what you can do, because it's so obvious that these are the same, is you can remove them. As long as they're the same name as the value that Rust is expecting for that struct, you can just pass in the function argument straight into the struct instantiation. So let's talk about struct update syntax. So we have these two structs here, right? And they're two students, but as you can see, they're relatively similar, right? And so the bottom two values here are the same, and we want to actually create the second student by using some of the values from the first. So that way we're not duplicating all of this data, right? We'd rather have some of this hard-coded in one place so that we don't have to type it out 15 different times. And so one way to do that would be to instead use dot notation. And so as you can see here, we have this dot notation, and now that's taking it from student 1. However, this is obviously kind of messy. You have to write all of this out, and it gets pretty boring pretty fast, and it's boilerplate. So what Rust allows you to do instead is to use the dot dot notation. And so what this does is it will actually take the values from student, and it will then say, okay, anything that hasn't been explicitly instantiated, go and take it from this other struct, right? And remember, these need to be the same type, but this allows you to have a little bit more freedom in not having to instantiate every single member from like different values. And finally, let's talk about tuple structs. So tuple structs are the idea that if you want to name a tuple, you can do so using a tuple struct, right? You don't have to have this tuple be a nameless object where you could mix the two up. And so they're their own type, even if they hold the same data as another type, which is really nice because let's say you have, say, a user class that has 3 floating points, right? Maybe it's like the health and their energy and some other third variable, right? Now, comparatively, let's say you also have a position struct, right? Or a position tuple, which has x, y, and z. If these values look the same, you might mix them up in the wrong place. And so to avoid that, you can create a tuple struct for both, and that way you avoid it. And so how you do that is you simply do struct position, in this case for an x, y, and z, and then you put in the types that you want. And so now you can't accidentally pass a position tuple struct into, say, a user or player struct location. And this allows you to have a named tuple as opposed to just a nameless tuple. So yeah, that is structs in Rust. Rust structs are obviously not too bad. They provide a way for us to get data across, and it really helps us make sure that we know what we're doing when we're passing a lot of data around. In the next video, we'll continue to talk about Rust. Until then, have a good day.